Hello everyone, welcome to DG Mento. Let's start solving this question. So I'm giving a minute time to read this question properly so that you can think about this question and I will help you to solve this question. So everyone read the question properly and let's discuss how to solve this question. Okay, everyone, so let's discuss this. Consider a Boolean expression given by f, x, y, z, and these are the midterms given to us. Which of the following statements are correct? So, the following sentences you can see option A, option B, option C, and option D. Option A is max term are given. Option B is minimized minterm is given. Option C is asking about the independent of input y, and option D is asking about independent of input x. So from all the options here we have got to know that it is revolving around the equation. Whatever the equation we are going to get, from that we can get to know what is max term, what is the minimal mean term, okay, minimal expression, what is dependent, what is independent, everything from the single expression we can get to know. And here is the hint that by using K map we can form a equation. So clearly from the options you can get to know how to proceed with this question, right everyone? So midterms are given to you and it is very clear that with the K map we can solve all this option. So let's draw a K map for this. Like this it will be. So it will be of 8 cells. So let's try to write the 8 cells. Like this. Here will be X. Here will be YZ. It will be like this. This will be 0. This will be 1. This will be 0, 0, 0, 1, 1, 1. And after that 1, 0. Like this it will be. After that, so the cell number, now what will be the cell number? This is 0. This is 1. This is 3. This is 2. This is 4. This is 5. Alright everyone, this is 7. This is 6. So let's mark it up now. So this is 3. It will be here. After that 5. After that 6 and 7. So can you all make the table? Okay. And they are asking for the max term. So let's see the max term. So in the max term it will be all 0. So here you can see that 0 is there. Here 0, 0, 0 and 0. All this 0 will be filled and this is the indication of max term. So in the 0th cell 0 is there. In the first cell also 0 is there. In the second cell 0 is there and in the fourth cell 0 is there. So from this K map it is very clear that option A is absolutely correct. Even without making the expression we can identify this way. Now let's try to minimize this and let's form a expression and let's see what the answer we are going to get. So this one is going to cover this way. After that this one is going to cover this way and this one is going to cover like this. So 3 expressions will be there. This clearly says what? YZ. This clearly says what? Okay. So 0 and 1 will get cancelled. What is the common you can get out of from this? YZ, right? And this particular box will get you what expression? So it will get, so X will be there. After that, what is the common you are going to get? Y. So XY we are going to get, right everyone? So what is the equation we are going to make from this? XY plus YZ plus XZ. So can I say that option B is also correct, right? Now let's talk about what is C and D. Okay, so C and D options are not correct, because x, y, z is independent of input y. So, but here y is present. So, how it will be independent? It is definitely dependent, right? Because the minimized expression is not independent of from x, y, z. So, this is clearly false, and same goes for y, because we have in the expression x is there, so it is not independent. So that is why C and D are not the correct answer. So here I can say that option A and B are correct. Option A and B are correct. So I hope you got the explanation, everyone. Now let's see the next question. Okay, so one question, this one I had given you for the homework. So let's try to solve this. Read this once again. Okay, and let's try to solve this question now. Yeah. So consider the following read-write schedule S over the three transactions T1, T2, T3, where the subscript in the schedule indicate transaction IDs. These are the transactions given to us, which I have already made. Which of the following transaction schedules are conflict equivalent to S? So for conflict equivalent to S, what are we going to make? We are going to make the polygraph, which is okay for the all the transactions. And let's see, let's check what we can get from this. Okay, so let's make the graph T1, T2, T3. After that, let's see the conflicting pair. R1 of Z is having any conflict here? No. After that, we are going to check for W1 of Z. Are we going to get any conflicting pair? No. After that, this, are we going to get any conflicting pair for X? Absolutely not. After that, let's see for this. Are we going to get any conflicting pair? Yes. So 3, 2, 2, we are going to get a conflicting pair. So it's going from 3 to 2 like this. This is how we are going to get. After that, so this is topological order, topological graph also we can say. After that, from this again same, and this doesn't matter. Now all this transactions doesn't matter because we don't have anything for the transaction T1 and T3. So the only graph we can draw like this. Now, so this is completely a cyclic graph. So I will write a point here. So those who don't know about this point, please note it down, because we are also revising the concept. The graph is a cyclic, it is conflict serializable schedule, and its corresponding conflict equal schedule is based on the topological order for the graph. Okay, for the graph. So what are the topological orders? Let's see. So you can see that we can start with T1, we can start with T3. So let's try to start with T1. So let's say if we remove T1, then T3 and T2 will be there. So T3, T2 will be there like this. What if I start from T1 now? Okay, I start from, T1 completed. If I start from T3, so this transaction will also get removed. So either it can be T1 or it can be T2. So let's first take T1. After that I can take T2. Similarly, T3 is there. So I can start with T2 also. I can start with T1 also. So these are possible conflict serializable, conflict equal in schedule to S. So let's check the option which is the correct one. So here T1, T2, T3 is given, which is wrong. After that, you can see here T1, T3, T2 is there, which is correct. After that, T3, T2, T1, this is also correct. After that, T3, T1, T2, this is also correct. So we can say that option B, C, D are absolutely correct. Okay, everyone. Now let's see the next question. So try for this question, everyone. So read at least this question. I'm giving a minute time. And read very carefully, note all the points so that you can understand what I am explaining. Alright? So waiting few seconds. Yes, so let's see this. Consider the following C function definition. It is given, the program is given to us. Which of the following statements is are correct, is are true about the above function? Option A is if the inputs are x equals to 20, y equals to 10, then the return value is greater than 2 to the power 20. If the input are x equals to 20, y equals to 20, then the return value is greater than 2 to the power 20. If the input are x equals to 20, y equals to 10, then the return value is less than 2 to the power 10. If the inputs are x equals to 10, y equals to 20, then the return value is greater than 2 to the power 20. So, what we have to see here, we have to let something, okay? So, we can do like this. So, see, here if you take the equation, so this is the function x and y values are taken, I equals to 0, I smaller than y, after that I plus plus, and the x equation is given like this. So x equation we can consider here x plus x, 2x plus y. Okay, so when I is equals to 0, then it is 2x plus y. When I is equals to 1, it is 2x plus y, like this, 2x plus y, okay, which is if you solve this, so it will be 2 square x plus 2y plus y, okay, and you don't have to generalize this, okay, please don't solve, we have to generalize this one. And if I say I equals to 2, then it is 2 square x plus 2y plus y plus y, like this. So which is 2 cube x plus 2 square y plus 2y plus y. Now we have to generalize equation for the ith iteration. And how we can do this? So for the ith iteration, the x will be, now see this carefully, whenever the x is 2, here is I plus 1. So 2 I plus 1, like this, into x is there. After that plus, after that here 2 is there. So this is 2i plus 1 minus 1, and here y is there if you simply see this. Okay everyone, so like this you have to see. The general equation will be like this. Okay everyone, any doubt here till now? Or you can also take common from this term. Okay, if you take, so x equals to 2 I plus 1, here x will be remaining, okay, plus y, and minus y will be there. Like this it will be. If you multiply this and this like this, so after that you will get to know what we are exactly doing. So if you take common from this, so this is the equation we are going to get. And here in place of x I can write t y minus 1 is equals to 2y x plus y minus y. So all I have turned this way. Now what is the thing what we have to do? We have to generally substitute the value now. Okay, so let's take this equation. So I hope how to form the equation is clear. So from this I am taking this in the other page, and after that we have to check the options one by one now, and let's see by which option it matches. So yes, the equation is here, right? This is our equation. Now let's see the options one by one for this. Option A, x equals to 20, y equals to 10. Let's put the value now into this equation and let's see what is the answer we are going to get. So t 9 will be there. After that t to the power 2 to the power 10 will be there. This will be 30. Okay, minus 10. Now what they are saying that then the written value is greater than 2 to the power 20. So is this greater than 2 to the power 20? Now if you just see this just one number, okay, so exponentials you have to focus on. Otherwise these are very small number. Only the exponential if you will see, you will get the clarity. These are very small number. So 2 to the power 10 into 30 minus 10 is not at all greater than 2 to the power 20. So this is absolutely wrong. Okay, so B option is wrong. Now let's verify A option is wrong. Now let's verify option B here. X is 20, y is also 20, and now what is the equation we will be getting? T19 is equals to 2 to the power 20, 40 minus 20, and this is greater than 2 to the power 20. Now here 2 to the power 20 is there, 2 to the power 20 is there. It is additionally getting multiplied to 40 and it is just subtracted by 20. So this is a clear condition that yes, option B is correct because it is greater than 2 to the power 20, right? Option B is absolutely correct. Now let's verify similarly for option C. So for option C, x is equals to 20, y is equals to 10, okay? So it will be T9, which is 2 to the power 10, 30 minus 10, which is smaller than less than 2 to the power 10. So can we say that it is smaller? Absolutely not. Why? Because here itself we are multiplying by 30. Okay, so this option is also wrong. After that, let's see the option D. X equals to 10, y equals to 20, like this. So T19, which is 2 to the power 20, 30 minus 20 greater than 2 to the power 20. So can we say that yes, it is greater? Okay. So what is the correct answer? B and D are the correct one. Okay. So the correct options are only B and D. Okay. So if you will see the iteration, then you will clearly get to know. Okay. So just 2 iterations and we have formed the general equations for the ith iteration, right? We don't know the value of 20. So for this, we have generalized everything, right? X we have taken as y minus 1. Okay. So like that generalization we did and we have got the answer. Okay everyone, I hope there is absolutely no doubt now. After that, how you have converted x to y? So from simple equation we can do x like this, y minus x equals to y. Okay. After that, in terms of like here it can be x plus y equals to 0. This we can do, but it's not needed. Okay. Directly we can just write this. So no need to complicate this. Just simply you can also put the values like this and you can check for the y. Okay everyone. So I hope the question is absolutely clear. Now let's see the next question. Or simple, if you are not getting this, how the equation is formed, you can also check from this equation. You will also get the answer from there also. So for example, I will tell you. Okay. So you just remember here, whatever is I, x coefficient is greater than that. Okay. So x we can take anything. So for example, option A, how to verify? By just this equation. By just simply this equation, how to verify, that I will show you. If you are not able to make this, so see, x equals to 20, y equals to 10, y equals to 10 and I also will be equals to 10. Okay. I will also be equals to 10. Like this, if you do, or let's say I is smaller than, so we can take it as 9, because see, we cannot take equals to value, so I we have to take it as 9, right everyone? So how the equation will be now? So x equals to 2 to the power 10 into x plus, so this like this you can make. So for the second, 2 to the power 20, this one you can just follow up. Here I is 10. After that, x plus y 30 minus y is 10. Okay, which is greater than 2 to the power 20, like this. So can we say that this is greater? Because this is not greater, 2 to the power 10 is there. And after that, this is the written value of x we are going to get. Okay, so written value of x. So this is the written value of x, which should be, they are saying that it should be greater than 20. So are we going to get the answer? No, not at all. You can solve either by this equation also, or you can solve this equation also. And those who haven't got how this x plus y came, so let me show this quickly. The explanation, I plus 1 is there, x is there. After that, multiply this y inside. I plus 1 y minus y, this way. After that, if you will take these term common, so yeah, here it is plus. After that, 2 I plus 1 x plus y is taken common, and after that this minus y I have written like this. So from this equation only, from this particular equation only, you can solve the question. If you haven't understood this and the students have understood this, they can solve by this. Okay. So I hope now there is absolutely no problem in solving this question. And remember, I value you have to take less than y. So I have taken here y value is there 10. I have to take I value as 9. It will never be 10 because it is not at all equal to. Otherwise the loop will fail. Okay, so I'm clearing out the mess so that you can just note the proper points for this question. So this is a very tricky question. So it's hard to think like this in the exam, but still for the next, for the 2025, you have got the idea if such question comes, so how you can just attempt the question. What is the logic you can think about so that such questions can be easily solved by you all. So that is why it is very, very important to understand and learn from the questions asked in the previous year. Alright everyone, I hope there is absolutely no doubt now. Let's move to next one. Okay, so please see this question everyone, and we will try to solve this question after that. So few more seconds I am waiting so that you all can read, and after that we will solve this question. This question is also very, very tricky. Okay. Okay, so let's see this question now. Let A be any n into M matrix where M is greater than n. Which of the following statements is are true about the system of linear equation Ax equals to 0? Okay, so the first option is given. There exist at least M minus n linearly independent solution to this system. Okay, so if we consider rank of A smaller than equals to n, so number of free elements, or we can say free columns, is greater than equals to m minus n. Okay, and number of linearly independent solutions, which is equals to number of free variables or free columns, I can say. So that is why this is absolutely correct. Okay, now let's see the second option. There exist m minus n linearly independent vectors such that every solution is a linear combination of these vectors. So from this option A, there can be at least m minus n free columns so that there are at least m minus n linearly independent vectors. So I am writing the solution B in the next page so that you can refer that all the time. I am writing the first one. Rank of A smaller than equals to n. So number of free variables, or I can say number of free columns, greater than equals to m minus n, and number of linearly independent solutions equals to number of free columns. it will be columns. Okay, so that is why A is correct. B, let's write. So from above explanation, there can be at least n m minus n free columns. So there are at least m minus n linearly independent vectors such that every solution is a linear combination of these vectors. So from the given statement implies exactly m minus n linearly independent vector, which is wrong. Okay, because it can be more. So that is why this is wrong. So B is not correct. Let's see now D. C. So C statement says there exists a non-zero solution in which at least m minus n variables are 0. So I will correct the C statement, okay, little bit when it can be correct. So I am writing this. Let me write this in the next page. See, this statement is true only if rank of A smaller than n. Then we will have at least m minus n plus 1 free columns. So there exists non-zero solution in which at least m minus n variables are 0. So that is why this statement is also false, not correct. Now let's discuss D. So D is saying there exists a solution in which at least n variables are non-zero. Now let's see this. For any solution vector x, so x will be, okay, it will be x1, x2 till xn, like this, xn plus 1 till xm, it will be like this. So this clearly will be n pivot variables. This clearly will be m minus n free variables. Okay, so I will write the point on the next page, and I am writing this so that it can be useful for you all to note and you can learn from this. So for these n pivot variables to be non-zero matrix A must be, or A must have rank of A equals to n. But if rank of A smaller than n, then there will be then there will be less than n pivot variables which have non-zero value, So that is why statement is also, this one is also false. Okay, everyone. So that is why this one clearly we can say is the false one. So which is correct from here? Option A only. A is only correct. So I hope you got this way, everyone. We can also discuss the another way for this if you all want. Okay, so I will be writing few points and these are very important one. So please listen carefully. The alternate solution for this one only. So I'm writing few points. Listen carefully. A is a matrix of dimension m cross n such that m is greater than n. This is given to us. Okay, implies that there is at least m minus n free variables, implies that there is at least m minus n linear independent vectors in solution space of Ax equals to 0. Okay. So this is what we can infer from this. So a matrix is of dimension this and m is greater than. So from this we can infer this 2 point. Now straight away we can check option A. Option A is the first one. Okay. What is option A? There exists n minus 1 linearly independent solution to this. From these two inferences, okay, we can clearly say option A is true. Okay. Now if we assume that, so what if there is less? Okay, let's try to assume this, that there is less than m minus n linearly independent vector solution to Ax equals to 0. So see, if those linearly independent vectors are solution to, wait, I will write if those linear independent vectors are solutions to Ax equals to 0, then their linear combinations also solution to Ax equals to 0. And from here we can infer some points I am writing, which implies that there is less than m minus n free variables, okay, which implies that there is at least n plus 1, which we can say it like m minus n minus 1 pivot variables. Pivot variables. So, which implies that there is at least n plus 1 linearly independent vectors in A. Okay? Vectors in A. Now, just think for a moment that in a matrix of dimension n cross n, we will have almost n pivot variables. Almost. But what we have arrived with the conclusion that it will have at least n plus 1 pivot variable, which is a contradiction. Okay, which means the assumption which we have created here, the assumption that it should be less than n minus 1, this is incorrect. So that is why if this is incorrect, then less than is not the correct one. It is at least n. Okay, at least n minus 1 is the correct one. So from this I can say that option A is absolutely correct. And this is the assumption. So this is by contradiction method we have proved. So we have assumed something correct, and after that when we have done the implication and we have derived it, so we have proven that our assumption is wrong. All right everyone. So I hope this is A option is absolutely clear. After that I can similarly say option B. So how option B is false? Let's see. So because it's not always the case that every solution in x equals to y is a linear combination of m minus n linearly independent vector. We can consider a case, okay, where so this is a case which we are considering where there are less than n linearly independent Si in independent in A, then in this case we need more than m minus n linearly independent vectors, okay, such that every solution of Ax equals to 0 will be linear combination of these vectors. So one example also we can take, okay. So let's say A I have taken 1 0 2 0 0 0 0 like this, okay, where for this matrix solution space of Ax equals to 0 will be what? It will be x2 minus 2 1 0 it will be plus x3 0 0 1, okay, where x1 and x2 and x3 belongs to real number. So we can clearly see that just by doing m minus 1, which is coming as 1, so linearly independent vector cannot generate all solutions in Ax equals to 0, right? So because of this it is false. But when it can be true? when they have mentioned the number of linearly independent vector in A is equals to n. So then we can represent every vector in solution space of Ax equals to 0 as linear combination of n minus 1 linearly independent vector. Okay, in that case, which I have already written. Alright, now I will also tell why C is false. So let's consider vector again 1 0 2, sorry, matrix 0 1 3. Now here space, so solution space, solution space of Ax equals to 0 will be x3 minus 2 minus 3 1, okay, where x3 belongs to real number. So if we observe carefully, then here x3 equals to 0, so it will be 0 solution, but our main interest is non-zero solution. Second is, if x3 is not equals to 0, then it will be a non-zero solution, but every variable is non-zero, which means that there is no non-zero solution which has at least n minus n zeros. So that is why m minus n zeros, so that is why C is false in this case. D is false. How D is false? So take this again, 1 0 0 0 1 0. Now the solution space will be here x3 equals to 0 0 1, this way, where x3 belongs to R. Now here if x3 is equals to 0, then it will be a 0 solution, and x3 is non-zero, then every solution has at least one non-zero variable, but here n equals to 2. That is why this is the contradiction of the option D. So D is also false in this case. So now I think it is absolutely clear why the options are incorrect. Okay, so two types, you all can think about it. Okay, two ways. Alright everyone, let's see now the next one. So try to attempt this question, try to try to at least understand and read the question very properly. So I'm giving a minute time. Done everyone? Giving few more seconds, think about it, read the question very properly. Okay, so let's read this question. Consider the 5-state DFA M expecting the language L, M, so M is there, belongs to complete language 0 plus 1 star shown below. For any string W belongs to this complete language, let N0W be the number of zeros in W and number of ones in W's be the number of ones in W. So this is the case. Okay. Alright everyone. So when we try to minimize this DFA given, we can notice that 3 and 4 have the same inward and outward transactions and they are indistinguishable. So same for 2 and 5 also we can consider. So 2 and 4 are indistinguishable because they have transactions from state 1. Okay. So if we final minimize DFA, we can clearly see that there are 3 states 1, 2 and 4. Okay. From any given string with the equal number of zeros and ones, it will be accepted by the DFA. So if you just minimize this, so it will come like this 1. After that here like this. So this is 2, this is 4, this is 0, 1, 0, 1, 0, 1. This is the minimized one we are going to get. So clearly it is very clear, okay? And yes, so this is one way by which you can do, or see options by option also we can check. So option 1 is state 2 and 4 are indistinguishable in M. So if you just see 2 to 0, where we are going to get 3. If you see 4 to 0, 4 to 0, so 4 on 0, where are we going to be? 1. Okay, on 1 we are going to be. So on 3 this is non-final state and 1 is final state. So that is why it is distinguishable. So we can say that A is correct. Getting everyone? Let's check for B. So state 3 and 4 are indistinguishable. So what we have to see here. So I'm writing the explanation for 2. So this is 3 to 0. If I will go 3 to 0, I will come to 1, right? After that, again 4 to 0, if I go 4 to 0, I am coming to 1. I am coming to 1. Now 3 to 1. Let's see transactions from 3 to 1. So 3 to 1 I am coming to 2. And transaction from 4 to 1 now. Where I am coming 4 to 1? I am going to 5. So here I am going to non-final state. Okay, I am coming to, yeah, so this is I am coming to final state, everyone. 1 is final state. And after that, 2 and 5 are non-final state. So this is clearly non-distinguishable because they are giving the same output. So how we can distinguish 3 and 4? Not possible. That is why B is not correct. Okay, B is not correct. Like 2 and 4 we can easily distinguish. By 0. They are coming, one is coming in the non-final state and one coming is the final state. But here both of them are not distinguishable. That is why B is not correct. Now similarly, can you check for 2 and 5? For both 0 and 1. So yes, let's check for 0 and 5. So 2 on 0, 5 on 0. After that 2 on 1, 5 on 1. Let's see now the result. 2 on 0 getting 3. 5 on 0, 5 on 0 getting 4. After that 2 on 1 getting 1. 5 on 1 getting 1. So here these are non-final state and these are final state. Again we are going to get the same. So how we can distinguish here? That is why C is also incorrect. Okay? That is why C is also incorrect. And if you see for the option D, any string W with number of zeros of W is equals to number of 1 of W is in LM. So just by making a string, we can have X amount of zeros. We will always get some amount of Y from the DFA. That is why this is also Okay, so what we want, correct or not we want? Okay, we want the false, right? So that is why this is correct. So A and D are the correct one, but I am highlighting the false one. That is why do not make a mistake while reading the question. Okay, right now in the mind, I was thinking that we have to find the correct one. But when I saw this, what we want, so always do recheck that what we want. We want the false one. So that is why B and D are not the option, but B and C are. If you try to make any string, you are going to get the same answer. Okay, for D. So it will be equal for the anything. Alright, so 0, 0, 1, 1, they are going to get the same one. So I hope this question is absolutely clear. B and C are the correct answer. Let's see now the next one. So solve this question, everyone. See, the chromatic number of a graph is the minimum number of colors used in proper coloring of a graph. Let G be any graph with n vertex and chromatic number k. Which of the following statements are always true? So first option is false. Why? Because chromatic number k is not necessarily mean that the graph contains a click on k vertexes. Let's say we can take one example. Chromatic number of cycle of graph on odd vertex is 3. But it does not contain any complete subgraph on 3. So that 3 vertexes. That is why A is not correct and we want true. After that, second, if you see, G contains an independent set of size at least n by k. So this is true. Why? Because if you see pigeonhole principle, if there are k color classes and n vertexes, then one class size is at least n by k. So we have to note that a color class is nothing but an independent set, right? That is why B is correct one. If you see G contain at least k minus 1 by 2 edges. So this is also correct because number of edges between k color classes is ck2 like this, or we can say that like this it is. Okay, which is, that is why C is correct. K chooses 2. Okay. After that, fourth one, if you see, G contains a vertex of degree at least k. So this is false because if you take a cycle graph on odd vertex, chromatic number is 3. But the degree is not 3 for any vertex. So similarly, for any complete graph, degree for every vertex is n minus 1. But the chromatic number is n. So should I note this point for you all? Very, very important. For any complete graph, degree for every vertex is n minus 1, but chromatic number is n. So very, very important point, everyone. Okay, so please read this question and you can take this question as a homework question. Okay, you can check this for the homework question, everyone. So till now we have solved PYQs. Okay, so part by part we are releasing the solution, detailed solution, as you can see, of the PYQs of specially GATE 2024. Okay, because whatever has asked earlier will give you the idea to solve the questions. Okay everyone, so please do check it out, the other solutions as well. They will be really, really very helpful, and drop the comment if you need any more video on any such topic. Okay everyone, so see you in the next video with the explanation. Thank you so much everyone.